Hey there! Today we're going to continue our journey with bases, other bases. We had already looked at an assortment of ancient number systems, and in the last video we first started talking about place value or positional value numeration systems, including the Babylonian numerals and the Mayan numerals. Well, today we're going to take what we learned from there and generalize it for other bases. Including binary and base 12, base 16, like all kinds of other bases. Like how would you convert from base 10 in our system to other bases? So plenty of examples that we're going to go over today. Now some important bases that you can see elsewhere besides the base 10 that you're used to are base 2, binary. I keep referring to that. It's the internal language of computers. Also can be the language for barcodes, which we're going to talk about in another unit down the road here in this course. Binary, you got zeros and ones. Another, you might see base 8 when looking at computers again, or if you're looking at ASCII code. That's also considered octal. Of course, base 10 is our decimal system. Base 12, duodecimal. You see some remnants of that in measurement, like when you see that 12 inches are in a foot in our system here in the US. Base 16 or hexadecimal. That's often used by computers to communicate with other devices like printers. You might see that in HTML code, other more computer-related things. And then as mentioned before too, the base 60, that sexagesimal system, we see that in time and navigation. So 60 seconds in a minute, 60 minutes in an hour, or degrees, minutes, seconds. You're still 60 seconds in a minute, 60 minutes in a degree. So those are some important bases that you'll see, but we're going to learn general techniques for converting, even if it's not one of these bases. Okay, so here's some basics. We've touched on these previously, but let's go over them again. You can use any counting number greater than 1 as a base. So you can have a base 2, base 3, base 4, base 5, base 6, base 7, base 8, base 9, base 10, base 11. Each base will have symbols for 0 through 1 less than the base. So like base 2 has symbols for 0 and 1. Base 8 has symbols for 0 through 7. That kind of thing. Now when you have bases that run into double digits, it's not practical to use double digits to represent a value. So often you'll start to see capital letters replacing. Like base 12, you need symbols for 0 through 11 in base 12. So you can use the same symbols that you're used to for 0 through 9. But when it gets to 10 and 11, you can't squeeze 2 digits into one place value space. So you use like capital A for 10, capital B for 11. That's one way to do that. And the same idea with base 16, another common base. A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. And in all these other bases, in order to communicate that you're in another base, you can use a little tiny subscript number for the base. So like if something's in binary, you would write your sequence of zeros and ones, and then you put a little tiny 2 to the far right bottom of the number to let people know that it's a number in base 2 and not in base 10. Because that's 11011 in base 10 is 11,011, while in base 2 is something entirely different. The only one that we don't usually write a subscript base number is in base 10. So if you don't see the little number, you can assume it's in base 10. But if it is in a different base, it needs that little number. And I'll show you as we do some examples. Okay. Now, converting between bases, just like when I ended the last video, if you're converting to base 10, the one you're used to using, you're going to multiply and add. If you're converting from base 10 to a different base, you're going to end up doing a lot of dividing. Very similar to our processes we were using for our Mayan and our Babylonian numerals before. All right, so let's just jump right into getting through some examples, because that's the best way to show you how this is done. All right, so in my first examples, we're going to convert some numerals to base 10. So I'll do a whole set of examples where we're converting to base 10, and then we'll do a set of examples where we're converting to a different base. All right, let's start out with something that seems kind of small. Let's say we have the number 2, 1 with base 3. So notice that, I wrote the 2 and 1 normal sized, and then I'm going to write the 3 like on the lower right, like, and it's smaller. All right, so if I'm in base 3, that means my positions are powers of 3. So like the 2 and the 1. The 1 is in the 3 to the 0 or 1's place. The 2 is in the 3 to the 1st or 3's place. So if I want to convert to base 10, basically I'm looking at, I have one group of 1 and 2 groups of 3. So I figure out what that comes out to, add it up, and then there I go. So I can do 2 times 3 here, and I can do 1 times 1 here, and I'm going to have 6 plus 1, which is 7. So 7 in our numbers is the same thing as 2, 1 in base 3. Okay, how about 7, 6, 5 in base 8? Okay, so again, whatever your base is, that's the powers for your place values. So I'm going to spread this out a little bit just to give us some room to work this out. Your 5 is in the 8 to the 0 or 1's place. Notice that that's always the 1's place, because every time it's whatever your base is to the 0 power is 1. So that's not too different from what we're used to. But here, instead of the 10's place, we're going to have the 8 to the 1st or 8's place. And then here we're going to have the 8 squared or 64's place. You're going to have to bear with me on some of these because sometimes I'm going to have to do a little bit of calculator work off screen. Sometimes I don't. All right, so here we go. Let's set up my calculator. So over here we've got 5 groups of 1. So we do 5 times 1, which is 5. Here we've got 6 groups of 8. So we do 6 times 8, which is 48. And then here we have 7 groups of 64. So we have 7 times 64. See, 7 times 4 is 28. 7 times 6 is 42. Plus 2 is 44. We're adding all those up. 13, 21, 6, 10, 5. So I'm getting 501 in base 10. So 501 in our numbers is the same thing as 765 in base 8. So converting from base 8 to a base 10, we end up having to multiply based on, sorry. You're going to find out I'm very corny, and even though I'm a mom, I tend to have a lot of dad jokes. But anyways, moving on. So you're going to do some multiplication. You're going to take how many are in that, you're going to take the numeral that's in that position, multiply by that place value, and then add up the results. Okay. How about, a binary number. I know that's everybody's favorite, it seems. 1, 1, 1, 0, 1, 1, 1. When I'm writing these down, I got to make sure I keep track of the correct number of 1s and 0s, because it's my eyes. I'm half blind. Literally, I'm blind in one eye, so it's like, I got to look and make sure I transcribe that correctly. All right, so binary. Like in our numbers, normally that would be 1,110,111. But notice that little 2. So this is binary. So I'm going to kind of write this out, spread out a little bit. So starting on the far right, I've got the 2 to the 0 or 1's place. Then I have the 2 to the 1st or 2's place. The 2 squared or 4's place. The 2 cubed or 8's place. The 2 to the 4th or 16's place. I'm running out of space. 2 to the 5th or 32nd's place. And the 2 to the 6th or 64th's place. All right, and since it's 1s and 0s, that gets really easy as far as trying to multiply and add. 64 times 1 is 64. 32 times 1 is 32. 16 times 1 is 16. 8 times 0 is 0. 4 times 1 is 4. 2 times 1 is 2. 1 times 1 is 1. and then add those up. 3, 7, 13, 15, 19, and 7, 10, 11. So what's 119 in base 10? In binary is 1, 1, 1, 0, 1, 1, 1. Put that little base 2 there. Yeah, binary, just a little quick side note on that. With binary, originally it was literally like series of ons and off switches. 1 is on, 0 is off. When we start looking at barcodes, you probably all have seen a barcode on a product you've purchased or something. You've got a black bar for 1 and a white bar for 0. And the sequences of 1s and 0s, they don't come out the same as what we're doing here, but certain sequences of 1s and 0s represent, the digit 0 through 9. So the computer can scan the black and white and take in the fact that it's 0s and 1s and then work with that. Okay, anywho, let's do some with the letters. Let's do a base 12. B52. Sounds like we're playing bingo. B52, and this is in base 12. So we're going to take this to base 10. All right, so you're going to find that I like writing it out like this. It helps me to organize everything with the place values and stuff. Now, B is like, oh yeah, what was that again? Well, base 12, you're going to have to represent the digits 0 through 11. 0 through 9, just use the same digits you're used to. 10 is A, 11 is B. So really we have an 11 right here with this B. So I like to write that down just to remind myself later so I can keep track. All right, and I'm in base 12, so far right, 12 to the 0 or 1's place. Then we've got the 12 to the first or 12's place. 12 squared or 144's place. Yeah, this is definitely one where I could probably do it without a calculator. All right, anyways. All right, so I'm going to be doing 11 times 144 for this. I'm going to be doing 5 times 12 for this. And I'm going to be doing 2 times 1 for this. So 2, 60, 144, 1, 5, 8, 4, 6, 14, 6, 1. So I get 1,646 when I'm in base 10. Woohoo. All right, let's do one more of these before we go the other direction. Let's do a base 16. D20E, and we're in base 16. All right, so spread them out here so I can organize everything. Okay, base 16, remember, all right, so A is 10, B is 11, C is 12, D is 13, E is 14, and then F would be 15. And then you stop there because base 16 just needs to go 0 through 15. Because as soon as you hit 16, then you're going to have an additional place value. And then you can use 0 through 15 again. But anyways. All right, so 16 to the 0 power is 1s. 16 to the first is the 16's place. Let me go and write down 16 squared and 16 cubed. And then I honestly don't know what those are off the top of my head. Let's see, 16 squared is 256. You would think I would remember that by now, but I don't. 256s, and then times by another 16, and you get 4,096s. Wow, this is going to be a pretty good sized number, isn't it? Okay, so we're going to be doing, yeah, I'm definitely going to need the calculator, because we're going to be doing 13 times 4096 here, plus we're going to do 2 times 256 here. We're going to do 0 times 16, that's easy. And then we're going to do 14 times 1, that's easy too. 14 times 1 is 14, 16 times 0 is 0. All right, 2 times 256 should be 512, but the 13 times 4096, let me do that real quick. I get 53,248. Okay, then I'm going to add them up. And I get 53,774. So that was my number in base 10. And notice I didn't need to write the little tiny 10 because base 10, if there's no number there, it was assumed to be in base 10. All right. Now let's go the other direction. Remember, going the other direction, we have to do a series of division. You know, going from a different base to base 10, we're multiplying and adding. But now going from base 10 to a different base, we're going to have to do a series of division. So let's go from base 10 to another base. All right. So let's start out with something a little smaller. Start out with 7. And let's go to base 2, or binary. All right. Now recall that we have to figure out, since we're going to base 2, we have to figure out the highest power of 2 that'll go into 7 without being bigger than 7. So I'm going to start with drawing my blanks. I know 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4. As soon as I get to 2 cubed, I get 8. That's too big. That goes past 7. The number we're trying to convert. So we don't need that. We're going to start with 4. We're going to divide 7 by 4. Whatever our quotient is, that's what goes in this blank. Then our remainder is going to get carried over to the next problem. So we're trying to break this down and see, how many groups of each place value do we have. So we're going to take that remainder of 3 and divide by the next place value there. We've got a 1. Then we've got a remainder of 1 that's going to go over here. But at the end, we're always dividing by 1, so whatever that number is going to be the number. And there you have it. If you lay it out like this, everything in the blanks will make up your new answer. And just make sure you put the little tiny 2 in there so that everybody knows you're talking base 2. Everybody knows you're dealing with 1, 1, 1 base 2, which is really 7 and not 111. See, drastically different. If you don't put that base 2, it's 111 in base 10. Very different than 7. So there's that. All right, 109, or no, yeah, sometimes, see, I just had an eye exam and everything looked the same, so I didn't get new glasses, but I swear, sometimes I have a hard time reading things still. All right, 190 to base 4. 4 to the 0 or 1's place, 4 to the first or 4's place, 4 squared or 16. You know what, I might have misjudged space here. Eek. Oh, no, I'm good. Because this is going to be 256. This is too big, so we don't want to go that far. All right, although I might run out of space trying to divide. Okay, so we're going to take the 190 that we're converting, and we're going to divide by that biggest place value that'll go into it without being too big. So we're going to divide 64 into 190, which will go in 2 times. 3 is too big. 8, 12. And if you're looking at it and going, did I go big enough? Your remainder should never be bigger or the same as your divisor. So the 62 here, the fact that it's less than 64, means I went in as high as I could. So that's good. If your remainder was the same or bigger, then oh, actually I could have gone in with a higher number. All right, so then I'm going to take the 62, divide by that next place value of 16. See, I'm running out of space. 4 is too big, that's 64, so 3, which is 48. So put a 3 there. Then we're going to take the 14, divide by 4. So put a 3 there. And of course 2 divided by 1 is just going to be 2 still, so we're going to be putting a 2 there. So we have 2, 3, 3, 2 in base 4. You know what? I had a different problem circled, but I really want to get something in there with a 0. I was going to do a base 8, but you know what? I think you guys can figure that out. Let's do one that has a 0 in it so you can see how that works. How about 73 to base 3? So let's do that one, because sometimes it's a little confusing, like how it works when you're going with a 0 somewhere in the middle of the number. And then we'll do a base 12 and a base 16. All right, 3, 3, 3. So we got 3 to the 0 or 1, 3 to the first or 3, 3 squared or 9, 3 cubed or 27, 3 to the fourth or 81. Okay, that's too much. So we're going to start with 27. Also, if you ever start dividing and you find that you're going to end up putting a digit up here in the blanks that's the same or bigger than your base, then you know you didn't go high enough. Like if you divide and you get a 4 and you're trying to convert to base 3, 4 doesn't exist in base 3. So, you know, you should be getting a 0, 1, or 2. So if you get a 4, you're like, oh, I didn't go high enough in my place values. All right, so let's try 2. Okay, so 2 will go here. Bring the 19 over. 2 will go here. Bring the 1 over. 3 that goes into 1 0 times. So you're going to have a 0 there. And of course 1 divided by 1 is 1. So I just want to show you an example where you ended up with a 0 in the number. It happens. Or if you have something that ends in 0, just be really careful. Don't lose track of your place values. Like if you have something that ends with 0 in the ones place, make sure you put that 0 there. Otherwise, it's not the same number. Like, So your book doesn't really, so I thought of that example, but your book doesn't really have one there. I wish it would have a little more variety. It just makes it easier when I'm trying to come up with stuff to show you. All right, you know what? Let's do real quick. Let's say that you're trying to convert something like 20 to base 2. I think that'll work. Yeah, this will work. All right, so let's say you're trying to do that. So a little unplanned example. 2 to the 5th would be too big. That's 32. All right, so stopping at 2 to the 4th. So we're going to divide 20 by 16. Goes in 1 time with a remainder of 4. Then we're going to do 4 divided by 8. Goes in 0 times, remainder of 4. Then we're going to do 4 divided by 4, goes in 1 time, remainder 0. Please don't make the mistake I've had students make where they stop here and then don't finish. Because this is not 101 base 2. You still have 2 more place values to deal with. Now you have a remainder of 0, so then you know that from here on out, whatever you divide by is still going to be 0. So make sure you get those zeros in there. You have to have them because this is a place value system. If you don't, if you just did 101 base 2, that would be the same thing as 1 plus 0 plus 4, which is 5. And that's not the same number. So you have to make sure that you take into account those trailing place values there with the 2s and the 1s. And that's for any of the conversions. Just be careful of that, because I've had students make that mistake quite a bit. All right, so let's do a couple more. Let's take 13,312 and let's convert that to base 12. So we have 12 to the 0 or 1, 12 to the first or 12, 12 squared or 144. What is 12 cubed again? I know I did it earlier, but I do not remember. 1728. And I believe 12 to the 4th is going to be too big. Yes, 12 to the 4th would be 20,736. So stopping there. So we're going to take 13,312 divide by 1728. I'm going to use my calculator to speed this up a little. All right, I know it goes in 7 times. So 17 to 28 times 7 is 12,096. Remainder 1216. So we had a 7 here. So then we're going to take 1216 divided by 144. And I get 8. Sorry, squeezing that in there. Not always the best judge of space. 144 times 8 is 1152. Remainder 64. So put an 8 there. We got 64 divided by 12. So 12 times 5 is 60. And then 4 divided by 1 is going to be 4. So we have a 7, 8, 5, 4, base 12. That one did not end up using the letters, but, you know, it still worked. All right, let's do one more. Let's do base 16. This one will involve letters. I'm sure you'd be like, yay, I need to see an example of that. So we're going to take 39,885, and we're going to convert that to base 16. So once again, I'm going to need my calculator here. Okay, 16 to the 0 is 1. 16 to the first is 16. I believe 16 squared is 256, but let me double check. Yes, that's 256. 16 cubed is 4,096. 16 to the 4th is 65,536, so that's way too big. So we can stop there. All right, so we're going to take 39,855 and divide by 4096 to start. We're going to need a 9. Okay, so far so good. Then we're going to be doing a 3031 divided by 256. And for now, I'm going to put that 11 there. And I know it's wrong, but I'm going to put it there just to talk about it further in a minute. Then I'm going to take the 215 divided by 16. That's a 13. I know that's not what we're going to put in our final answer, but I'll just put it there for a minute. So I'm going to talk about that further. And then a 7. So each time you're taking your remainder, dividing by the next place value as you make your way from left to right. All right, so in the blanks, you see the 9, the 11, the 13, and the 7, and you're like, well, I know that doesn't make sense. But I think I might have made a mistake too. I wonder. Okay, let me double check this, because if I did, I need to go back and figure that out. All right. Sometimes I get going, I say, oh, I don't need to use my calculator. And you know what? I already made a mistake right there. I wonder if any of you caught it. That's a 6 right there. Did anybody catch that? Of course, you're not in class. Usually in class, I can hear the gasps of, oh, they're like, wait a minute. And then I hear the murmuring, like, oh, that doesn't sound right. So you know what? I'm going to have to do a little erasing. Let's see here. You know what? I'm going to erase that. Do it again. I can't hear your gasps, so I couldn't stop right away. But, you know, it's all good. But it never hurts to see the teacher's process. Things happen. We all make mistakes. It's okay. Just learn from your mistakes. Get them corrected, learn from them, move on. It's all good. All right, so this time I'm not going to try to... All right, so I know it went in 9 times, so that was actually still correct. 54, 81, that should have been 86. So sorry about that. Okay, so that's 30, 21 divided by 256. 6, 6, 4, bring down the 1. That'll go in 1. So that'll be 11. So again, we'll talk about that in a minute. So far, it wasn't that far off at least. But, you know, make one mistake at the beginning and it'll throw off things later in the end. So far, so good. And this is where I noticed my mistake. I was like, well, that's not supposed to... The answer I had earlier, it's like, that's not supposed to be that. Something's wrong. All right, there we go. Now, if you were to try to write this as like 9, 1, 1, 1, 2, 1, 3, base 16, that would not be correct. Because suddenly that would be a very different number. Because suddenly you would be having 1, 2, 3, 4, 5, 6, 7 place values. And you're not supposed to. You're only supposed to have 4 place values based on what we looked at here with the powers of 16. So that's why it's important to use the letters instead of the numbers when you have those double digits like that. So remember, A is 10, B is 11, C is 12, D is 13. So this is actually going to come out to 9, B, C, D in base 16. Yeah, this is not going to work up here because that would be an entirely different number. You can't squeeze 2 digits into one place value. So use those letters. That's why. So we have 9, B, C, D, base 16. I made sure to include my little 16. And there you have it. That was the last example I was going to do. Hope that is enough. If not, of course, you can always shoot me a message and I can make another short video. But that was it for changing bases. You might notice in your book that there's a lesson that gets into computations and other bases. We're not going to focus on that too much. I mean, you can explore it, but not going to be a huge focus in this, especially when it gets to the final exam and all that. We're going to skip over to early computational methods. That's going to be the next video, and then that'll wrap up this unit. All right, so I look forward to seeing you again soon. Thank you for joining me.